Hello again, I'm Bill Wagner,
And I'm James Sturdivant.
and we're here to continue our discussion of object-oriented practices and different ways and techniques that you can leverage the tools that we have to build great applications. So we're getting close to the end. We've got two more topics to cover on this tour of different application techniques, working through object-oriented programming and object-oriented design and building programs. This particular module is all on delegates and events. We're going to be talking about ways to have what we call outbound interfaces, where you're creating a class and creating an algorithm, and you need some code from the client objects that are going to work with your application in order to fulfill that entire algorithm. A classic example is sort that we talked about. And we've seen that in terms of the interface of iCompare that has effectively a delegate or a method on it. We're going to expand on that definition in terms of other ways classes can communicate outbound with other objects and other types that haven't been written yet, and make use of those and work together with those. So this is all about delegates, events, and lambdas. Lambdas are a type of syntax that make it easy to create delegates and events. So we've actually seen them already in that expression-bodied member that I used in a couple of the lab samples to create a very, very shortened version of a function. We find it a very, very concise, clear technique for implementing what would be an outbound interface where something else is going to call some method into what we're working with. In this module, we've got 4 different sections again. We're going to define both of these terms, and we're going to stress especially the distinction between delegates and events. They're very similar, and they have some nuances that are not well understood, especially by people approaching it for the first time. We'll talk about some of the guidelines as to how do you pick which one of those to use? How do you know when to use either of them? What kind of practices are going to be part of effectively using them? And we're going to look at what kind of code comes from effectively using them correctly and being able to see what kind of things and extra error checking maybe you don't need because you've picked the right tool. Let's begin by looking at the definition for both a delegate and an event.
So a delegate is a type-safe method reference, and it's used for defining these outward-bound interfaces. What it's really letting us do is be able to specify a function so that we can use that function later on. So we can specify the parameters that are going into the function and the parameters that are the return result that's coming out of the function.
So we don't actually write the function, but in terms of a delegate definition, we specify its signature, right? So.
Yep. And so then next up is an event. An event is a delegate with a specific format. So it's built on top of the delegate format, but you have to specify the sender and event args to the parameters that are going into the function. And it's used to define the outbound notifications. And so what we're trying to do here is we're notifying the users of our class that something is going on. A classic example of this is the click event. And when someone clicks on a button, it's going to fire an event so that the classes that are surrounding it and using it are going to be notified that the event has been fired.
So it's interesting, and the key word here on the difference. You notice these two definitions look a little similar. The first one we said it defines an outbound interface, and the second one we said for an event it defines an outbound notification. If someone clicks a button and no one's listening for that event, nothing happens, right? But if I go to try to say sort a list and I don't provide a delegate or I don't provide an implementation for the specific ordering function, that's going to throw a null reference exception. Sort needs to know that information. The button is more than happy to raise the event and say, okay, for anybody listening, it just got clicked. But if no one's listening, a button's fine with that. You know, just like there are other events on button for on enter, on blur, mouse move if it's inside its borders, and so on, that may be optional, may be part of your code. But if you don't need to, you don't need to subscribe to those.
Right. And so there's different ways to be able to define and implement these delegates and events. One of the ways that you can do that is using these Lambda expressions. So a Lambda expression is a shorthand syntax for these expressions. And they can be used to define the delegate instances or event handlers. And this is really just a shorthand way of defining a function in line with, in an easy way to describe what that function does. And we use these a lot when we don't want to go through the whole ceremony of creating a whole function outside on another class or
give it a name, have to have all this. And when someone's doing a code review, they see this function, they wonder where it is, where it's called. It's only being called to attach to this delegate handler. It definitely keeps the code more concise and keeps that definition of the handler or the delegate for a particular algorithm exactly with where it's used rather than some other place in the file. It does, over time, as you get used to the syntax, it certainly makes it somewhat more readable, I think.
Yes.
So let's look at the difference, I think, contrasting those delegates and events. As I said, they're very similar. We both are saying it's a way of defining the signature for something. You know, a class that raises an event is going to call the event handlers on it. A class that takes a delegate may call that method. You know, in both cases, they define those method signatures. They define the arguments. We define what the return value is. We haven't introduced that next topic, that single cast and multicast for a delegate. So what that means is a delegate can have multiple subscribers attached to it. And that's especially important in events. There may be multiple pieces of code that operate when that button gets clicked. So multiple listeners can be listening for those notifications. And a delegate, a variable of type delegate, can be null if we wanted to.
Okay. So one of the things that I asked you when we were preparing for this class was, what's the difference between the delegate where it defines a method signature and the difference between a method signature pattern?
Right. So with an event, if I'm going to define an event, there's typically a pattern that says an event is a specific type of delegate. It's going to have a void return. So there's no value returned from raising an event because there may be nobody listening. And it has this particular pattern where the first parameter on any event is the object that raised the event. And the second parameter on the event is of some type that's derived from system.event.args that will have information about a particular event. You know, in some instances, it may be event.args.empty, which has no particular event. In some instances, like say in a button, it may be exactly where it got clicked. You know, in other events, it may be exactly, you know, in an event for, say, a logger, it may be the message we want to put in the log and so on. So, but it has a very specific pattern. The compiler doesn't necessarily enforce this. You can use the event keyword to define an event and have a different signature, but there's a lot of code out there that's going to assume that something that looks like an event is going to have a signature with exactly those two parameters. First one's of type object, and it defines the sender, and the second one is of some type derived from system.event.args, and that is all the information that is passed along in the event. And a further part of that pattern is it may be true on any number of event styles that one of the properties inside that event.args derived object is for the event handler to communicate back to the code raising the event. This will be common in in systems where you may have an on button click, let's say, or on leaving a window or on closing a window is actually one. So there's, in the window class for desktop programming, there's an event for on closing, which happens when the user starts to click the close button, but the window hasn't gone away yet. And one of the return values from that, or in the event args, is a cancel flag. So if you have unsaved work, you can cancel that and say, I want to raise a message box and say, do you want to save your work or not? And set that cancel flag, and then the object that raised that handler will look and say, oh, somebody wants to cancel this. I won't continue closing the window. Other events like onClosed, which is after the window is closed, won't have that kind of a pattern. But there is a way to be able to communicate in a return value kind of sense, because the event handlers don't return a value. So that's the way they can communicate back if we need to.
Great. So we kind of looked at the differences in the way that these delegates and events look, but how do we start to look at how you're actually going to use them inside your code? Delegates generally are defined as methods that you will be calling with your class that has defined that method. And so you're really relying upon the calling class to define that method for you.
So when I look at any API that I'm using, and one of the parameters is some kind of a delegate, I expect that I have to fill something in there. I would expect that if I pass null in on that, it will probably do something bad, like throw an exception or do something. And if there's a type that has a member that's a delegate I'm supposed to set, I would probably expect that if I don't set it, bad things are going to happen in my code.
And that's probably because the code that defined that delegate is actually using that method that you're supposed to be defining. And if it's not defined, it's going to throw that null reference exception.
Right. It's going to call that delegate.
Yeah.
That's part of its general contract. Right.
Great.
And we can contrast that with events. So they'll be defining that outgoing notification, and it may or may not be called as part of its regular use. And that's up to the code inside. It will call that if you subscribed to the event or if other code is subscribed to the event. But if there are no subscribers, it won't try to raise the event, and it should not throw a null reference exception or some other kind of exceptional behavior.
Yeah, so your class is really not dependent on the definition and the implementation of that event.
Right. So like when I create a window object, I don't have to subscribe to all the events that it's going to raise or that it may raise. I only need the ones that I care about.
There's quite a few out there in the
There are quite a few.
So that you've got the mouse click, you got the mouse close, you covered a whole bunch of them there.
Move and all kinds of things. There's dozens. So we don't want to have to do that. So that's really that what you're communicating to developers reading your API about the difference between those two. An event is something that someone may be listening to, and a delegate is something that this class is going to call because it needs to in order to get some of its work done.
Okay. So I think I got a pretty good understanding of what delegates and events are. Where does the lambdas fit into all this?
What about lambdas? So lambdas allow us to define that method at the point of its use. So it's much, much simpler. It's much more concise. If I don't want to use the lambda syntax, what I would have to do is create some method inside a class, whether it's private, public, static, whatever. I would have to create that method, give it a signature, give it a name. Now it's going to be part of whatever developers read somewhere else to wonder where is this called, how many places is it called, and so on. Whereas if it's only called when I'm attaching it to a delegate variable or attaching it to an event handler, if I define it inline as a Lambda expression, when I'm reading that code, I can see that the only place this is used is as part of this delegate or in this event handler. It becomes a much, much simpler way to see that this piece of code is only used right here.
Great. So really, when we, I definitely have run into that before where I found functions on classes where I just can't find where they're actually being used. And what happened was that they ended up being used for one of these delegates out there, particularly in maybe some kind of method that's taking that function in. Mm-hmm. And so it's really great to be able to define that method right on that, define the method and the functionality right inside that method that we're implementing. Right,
because the flip side of that is then when you're looking at the code that uses that function as a delegate, you're reading this thing and you're looking at it and you see one of the parameters is the name of this function somewhere else in the class. So you have to, we have nice tools in Visual Studio to be able to F12 and see what the definition is, but it doesn't flow, it doesn't read as well, right? It's harder to see, okay, here's this query and now it's calling this function that's somewhere over here and I have to go look for that and find it and now I understand that and now I'm coming back to this. And just as we're reading things, it's harder to process. So it makes it more difficult for us as developers to read someone else's code and see exactly what it does, which, as we said in our introductory module, that's one of the big keys about understanding how and what we're expressing with any of these concepts is we want to make our code easy to read for other developers as part of our team or as people who may come behind us to add more features into the code that we write. And that's where I tend to trend toward using these Lambda expressions, which is where I just have that parameter list, then the big fat arrow, the equal sign, the greater than, and then the implementation body right there. It's easier to read because I see semantically what the implementation of that delegate is at the point where I pass it to this other algorithm. Mm-hmm.
So next up, I think we're going to talk about a few of the the guidelines when we're implementing delegates, events, and lambdas. So I think the first thing we're going to be taking a look at is when we have notifications that we need to push up to other classes, we want to make sure that we're raising events. So your class is going to define the event and the protocol that is going to be the receiving side of the event. And then your code, when one of these events happens, when the button is clicked, when the form is closed, it's going to raise that event up to all your subscribers. And so subscribers will actually register, and they can also unregister to any of the events that they're interested in. And so we kind of touched upon this already, but events, you don't necessarily have to have a subscriber, and you can have multiple subscribers. So you can have 1, 2, 3, maybe even all the way up to 10 or 15 or, you know.
Right. I don't know how often in practice I've seen a dozen subscribers, but it's certainly possible, right? If something's coming inbound, it's an event, the implementation of the event and delegate object in the base class library will automatically take care of handling multiple subscribers. So we don't have to worry about that in the code we write. But yes, by having that event, there may be 0, so there may be nothing attached to the event, and we'll have to implement that inside our class. We'll see an event handler, that event object is null, and then we shouldn't raise that event. But once again, we define the protocol. We say these are things you can be notified about. If anyone wants to be notified, they can subscribe. And one of the key things I think about this, by using this event-based model, there are no restrictions or assumptions about the type of code that's subscribing to an event, right? We don't have to define an interface to say you must implement this interface if you're going to subscribe to the events. We don't have to describe a base class. There's no restrictions whatsoever. Any other code in our application, if we have a public event, can subscribe to that event and process whatever work it needs to do when the event is raised.
Yeah, and that really makes your code a little bit easier to extend. So you don't necessarily need to know all of the use cases for this event firing off. And so you can easily add in this other event that's going to do this new implementation for you that you had no idea was something that they were going to use it for when you were implementing the class.
And it creates a very, very loose coupling, right? I can build this object and I can build this class and it will raise events. And I don't have to make any assumptions whatsoever or introduce any constraints on the subscribers of that event, right? So that's one of the big keys there. I don't have to introduce any constraints anywhere. There's no assumptions. Any code can work with it. It's very loosely coupled. Mm-hmm. Okay, and then the next thing that we led into this when we were starting to talk about generics is delegate arguments for different methods. They can express the missing piece of an algorithm, right? We write these generic algorithms. We were talking about that earlier. And how do we fill them in? Well, that looks like a delegate. It's a small piece of code, and we can define generic delegates to meet our need. And we'll concentrate on some of that more in our functional programming section because it's a key building block there. And for right now, delegates can define the specific capabilities for a particular API that we need to use. In fact, the term functional programming comes from the idea that a function is a piece of data that can be passed around just as other bits of data. Just like here's an int, no, here's a function. Okay, so delegates define those specific needs.
Great, and so I think we see this quite a bit in the link library, where if you need to order by a particular particular property, you're going to pass that property as an expression or in the delegate, and that allows us to not necessarily know what that is at the time. We're again breaking out that specific from the generic, and the specific is when the client is actually using the code. Right.
And where is another good example. So there's an expression, a delegate you have to pass to where, and where is basically a filter. So if I want to say, in our lab, I could define a query that says, I want to see all teachers who grade easily, right? So then I could write a where clause and say, this expression is going to return true if most of their grades are a B or above, and it returns false if the average grade they give is a C or below. And now I have to define that delegate that takes in a teacher and returns a Boolean. So it's a small little function to go to the where clause to filter for the results that I want. And the idea behind this, and where I think we're going with this, is it's very, very loosely coupled. I can add that functionality later with very minimal requirements. I just have to match that delegate signature that we talked about in that definition section. In the case of order by, it has to return a single property, and that property has to implement comparable of T for whatever type T that property is. In the case of where, it has to be a method signature that takes in the type of the sequence as its single parameter and returns a Boolean. Okay, it's a simple signature. Anyone can write that simple function. And what it means is by using delegates now instead of some of the other techniques we talked about earlier, we want to use delegates if we're thinking of using polymorphism to say, I can work with types that implement something, right? We could define some outbound interface as an iSortable or an iWhereable and attach this method as part of that. That's a lot of heavyweight work, and now all this code, we have to create a new type, it's going to have to implement this interface, it's going to be passed along. That's a lot of code to be able to do effectively ordering something or effectively just doing a filter. Delegates can be much, much lighter weight. So I can compose with other uses easier. We see that in LINQ when we can write longer queries with more different clauses to them. And we require only what's needed for a single use. Think of that idea of ordering something. We may order by different properties for different parts of our program. I don't want to create full-blown classes and have to implement some interface or grab a base class and do all that and have all that extra heavyweight work just in order to perform sort in a different order. I'm much happier if I can just write that one single function, pass it in as a delegate, and say, now use this for your comparison function.
Yeah, I think the LINQ libraries would be a lot less usable if we had to implement an interface every time we wanted to use the sort function or the where function. So now with these delegates, we're able to, and especially delegates involved with lambdas, we're able to define these functions on the fly, kind of as we're programming. It's a little bit more natural to do these things.
It definitely feels that way, and that's sort of our last big guideline is really consider that idea of using lambdas for those method definitions. Right? We can define the implementation just as a lambda expression, because often, when we're talking about these examples, those functions are going to be 1 or 2 line functions. They're not super big and super complicated. We can even define our event handlers as lambdas and attach it to an event. I can say, some object.on method plus equals, and here's a lambda. But I want to point out that this one is a guideline, not a rule. It's not something that would be wrong if you define the method and do things. It's more about how the code reads. If the functions are small, simple lambda expressions really make it read very easily as I read the function that uses it.
But if you're using the delegates as a way to define a very complicated algorithm that your class is going to be using, and that function requires quite a bit of code to implement it, it's not wrong to define that class or define that function on the class.
Right.
So you don't necessarily have to use the lambdas.
Right. And in fact, if you're going to reuse the same expression several times, it may be wiser to create an actual function for it and then pass the reference to that.
Yeah, that way you're not duplicating that code.
That way you're not duplicating that typing all over the place. So let's look at some of the practices in terms of working with delegates and events. So we've got a few different guidelines that we've talked about, and let's see what actually happens as we start building some of the code. Again, what we're really looking for, we want to separate that general from the specific. Again, sort is a great example. We keep coming to these classic computer science algorithms. LINQ provides a lot of great examples. The whole LINQ syntax is built on these concepts. If you look at, I would say, every method in system.link.enumerable, one of the parameters to it is going to be a delegate of some type. It's just all throughout that. We can really consider, and we'll find a lot as we start moving down this road, this is why we're covering this after generics, is we're going to find generic arguments throughout these delegates and events. Sort has got compare to of t, link, where, select, and all those generally have at least one generic argument. In many cases, 2 or 3. In order to make our lives easier, the base class library designers added a type called event handler of T a couple revisions back. So I can create an event definition by saying event handler of T, and T has to be derived from system.event_args. And it will fill in the rest of the signature, and I have an event handler of T. Just for whatever event args I happen to be using.
That's pretty nifty. The generic arguments really are, we're again making these algorithms that we've defined in a much more generic way. And so when we start to combine these things, we really see the power behind the generics. We really see the power behind defining delegates, and especially when we use them in combination.
And as I said, that event handler of T has that constraint added where T has to derive from system.event_args. So it's going to match that signature correctly. So we get to leverage that as well. So what kind of things, where do we see some of these in terms of raising events? A lot of the ones that I see, one of the common ones where you may define your own events is if you're going to look at progress reporting, that sounds like an event, right? I can fire off a task and start it, and I don't necessarily have to watch its progress. But if I want to, that feels like an event. If it raises events to say I'm 25% done, I'm 50% done, like some famous dialogues, I'm 95% done, I'm 30% done, and so on. Operations can report their progress also by logging messages. So if there's a system logging type, the logging thing might be a listener for events, and I can attach to that event handler, and I can raise messages to say, please log this. And a logger can then listen for different events on whether errors or diagnostic messages and so on. So I can attach event handlers and have a logging message just sitting there listening for events to come at it. Those are a couple different use cases I've seen on a lot of applications.
Yeah, I think the logging one is pretty good. I think we see that when we can specify different types of logging messages that we want, whether it's information or debugging or it's a warning or a progress. And so we can assign and register ourselves so that we can listen to those various types and do different things. That really allows us to be able to make that code very generic for when we're working with it.
Right. So let's finish up by looking at some of the outcomes when we're using these techniques correctly and when we're putting them in place correctly, what kind of things we see in the code and what friction we may not see when we're trying to work with things that we've built. So first of all, one of the biggest things I find when I'm using delegates and events correctly is I will find that the APIs and the algorithms that I'm putting together are very easily composable. So what that means is my delegates define the outbound interfaces. I simply need to implement that one method. If I want to make use of somebody's library, I don't have a lot of ceremony I have to do. I have to do just the work that's necessary to work with whatever algorithm I'm trying to attach to. And again, link here I think provides a fantastic example. If I want to run a link query, I just have to define the parameters to each one of those, where, select, and order by, inner join, group by, whatever it is I happen to be using, take, while, skip, whatever. I just have to define the minimum amount of stuff to use all of that great functionality that's provided.
Yeah, and that comes back to that composability of the functions that you're working with. So you don't necessarily need to know the solution. You can take this function over here and this function over here and kind of put them together and begin to build out this very complex query that you're going to be running against, whether it's an object or going back down to the SQL database in NAD framework and link to queries. But you get to compose these different components together, and it's very easy to swap out or stick another where clause on there once you've processed it for a little while.
And contrast that with, had the BCL team decided to do this by making us implement interfaces, to write a link query that had a where clause, an order by, and a select clause. If we had to implement 3 different classes, each implementing a different interface, or one class that implemented 3 different interfaces, that would be so much harder to read and so much more work just to use. We might actually just say, I'm not going to use this, I'm going to find something else. It's just, it should feel like it's easy to use. And that's really what we're striving for as we define our own objects and our own algorithms, is I want other developers to find the code that I've written to be easy to use.
Yeah, and we see that manifest itself through this weak coupling. So the link library doesn't necessarily need to know anything about the libraries that we're working with, and our library doesn't need to know too much about what link's doing. And so we no longer have to do these explicit interface implementations directly, and that really allows us to create these decoupled applications.
Right. So then our second nice good outcome is that we minimize name collisions. You know, one thing that we've kind of glossed over as we've talked about using this Lambda syntax is that when I define a delegate using the Lambda syntax, I don't have to give it a name. It's what's called an anonymous function. And because of that, I don't have to have extra names for different things that might be similar, right? It's just there. That delegate is just there. You read it when I'm calling the method where it's in place. I don't have to give it a separate name. And by not have to introducing more and more names, I'm less likely to have to worry about, I need a new name for this because I've used all the good names already inside this class.
If you had to implement a new name for every time you call the where clause, that would be very challenging.
Right. And because of that, then when I start looking at a large code base, you know, the names of public types, the public names, should refer to something in the domain. Right. It should be something that I really want to try to understand as I'm working my way around this code base and getting familiar with it. And that means having a smaller number of public names, because hopefully we keep that vocabulary down to where a new developer can come join our project and start to learn the vocabulary relatively quickly. And the more terms we have to throw out there, the harder that's going to be. So that's one of the other good outcomes when we put this in place. You know, when I look at this, one of the quotes that I really like, Anders Hellesberg, who is the designer of C# and a technical fellow at Microsoft working with several of the languages. One of the things he talks about when he's putting the tools together is he says that what his team actually creates as a product is developer productivity. Right? So all these tools that we have are meant to make it so that we can do more in less time. Right? And a lot of that means having a really rich palette that enables us to write code that clearly defines what our intent is. Some of it is being able to write a smaller amount of code, less typing, to be able to express what we want to get done. Right? And, you know, I don't want you to misinterpret some of the things we're doing here, where we're really talking about these delegates and events and saying there's a lot of cases where we really like them over polymorphism. I think if the BCL was all based on nothing but delegates, it would also be very, very hard to understand. You know, we want to balance these two. You know, we can see classes like our MVC controllers or our window classes or some of our other domain classes where we want those types and the class hierarchy and the polymorphism, and it makes sense. And we can see other algorithms and other pieces of our code where not forcing our clients to write more classes and more interfaces makes it easier to use. So we're really trying to strike that balance.
Yeah, and I think that's what we're trying to do with some of these examples in the exercises is really work that muscle to figure out where do you actually use delegates and where do you use interfaces, where do you begin to use abstract classes. We're trying to make sure that that you start to work that, because there's many times where you can choose one or the other, and it's not necessarily right or wrong. It's just what you decided at the time with the information that you had. And so I think that's a really great point that you brought up there.
Well, thanks. So, and with that, you know, we've added yet another one of those tools to work with. We're going to come back shortly, and we'll look at, in particular, Link and a few other areas in the BCL that make use of delegates and events. We'll talk about why they made the decisions they made, give you some lab exercises, and then come back and talk about one solution that we put in place. We'll see you soon.